My name is Joe Mazzola, and I am Plenary Keynote Speaker Chair at Inform Charlotte. It is my pleasure this morning to introduce Keith Collins, Senior Vice President and Chief Technology Officer at SAS. In this role, Keith leads the research and development, information services, and technical support divisions of the company. He fosters close working relationships with marketing and sales to ensure that SaaS technologies are aligned with customer needs and market demand. He has been instrumental in leading SaaS evolution as a provider of industry-specific solutions that deliver the benefits of powerful analytic technologies into the hands of users. In 2006, he established SAS CIO Customer Advisory Board, which brings together CIOs and CTOs from some of the world's top companies to provide guidance to SAS on future directions. He later launched a similar advisory board dedicated to analytics. A North Carolina native and graduate of North Carolina State University in computer science, Keith Collins is a devoted supporter of the university, especially its program in computer science. In 2003, the university named him Distinguished Engineering Alumnus. He is also on the board of the North Carolina Museum of Natural Sciences. Ladies and gentlemen, please join me in welcoming Keith Collins.
Good morning.
Good morning.
All right, now this is the fun part, because everybody that's standing up in the back, we got 2 rows of 50 seats still, so you can feel free to come on up. It won't embarrass me at all to have you walking up while I'm talking. How's everybody doing this morning? Good. So what would really make this session fun is if we go completely off script. And the way to do that is to ask either LaQuana or Luther here to bring you a mic so you can ask a question. Something that happens to me frequently is I will fall into some acronyms that you might not be familiar with. If that's the case, you should raise your hand. Because if you're not familiar with it, that means a lot of you probably aren't familiar with it. Or you might know it from a completely different term. Like SAS, what does it stand for? Is it Scandinavian Airlines, or is it Surfers Against Sewage? Neither of those, right? So I'd like to take you through at least my perspective of what's happening in this area of analytics and transformation. I woke up this morning and it's about 5 o'clock, and you're in that strange state of a little bit of sleep, a little bit awake, and I realized that I'm dreaming. And I'm dreaming about it. It must be a researcher in Antarctica. And I think, okay, this must mean something. Is it because I really want people here to understand that there is this transformation going on and that innovation is at the edge of these disciplines? That as we look forward, that there's this space between the data mining and econometrics and the optimization that we need to understand, because that's going to be something that really drives innovation going forward? Or was it simply that I wanted to be able to talk about data and big data and how it's changed? If you think about all of what we watched in Antarctica, you see they did all the journals and collected the data and studied it. But today we have that in terms of core samples and satellite samples and water temperature samples and sensor data. It's just inundating the process. So how do we stay ahead of that? Or was it more the case that as a computer scientist in front of all these great analysts, I feel like an Adelaide penguin in a room full of emperor penguins? Maybe that's it. But there's a tremendous amount going on in terms of an evolution. This, to set the stage, is just west of Charlotte. 1960, I-77 crossing 85 didn't exist. 2011, right? Top left corner, west side of Charlotte. Growing from about 200,000 people to 1.7 million in the metro. That's about a compounded annual growth rate of around 4%. Right? This curve, this accelerating curve, that's what I want to talk about. I want to talk about it in terms of what's happening to us in terms of technology. How many of you have read Ray Kurzweil's Singularity is Near? While not everybody might agree about whether or not we're actually going to be a combination of human and machine by 2035, I think the really important takeaway in that book is the combinatorial effect of technologies. That any single technology seems to have a fairly simple linear progression, but the combination of technologies creates this exponential curve that we feel like we're experiencing. Jim Collins just released a new book, and part of his discussion talks about how we feel so pressed now, that there's never enough time, that there's always so much information. And this was really what we're seeing, is there is this acceleration. It's never going away. It's not going to get any simpler. So what do we do to bring our technologies to bear to help manage that process? And as technology would have it, I did lose my wireless connection, so if you can advance the slide, right here we go. So this was a slide I used with the R&D team this past February. Huge impact on the team. We talk about this inundation of data. Well, what does it really mean? What's the class of that? And the most important takeaway, look at the blue line here at the bottom. That's transactions. Transactions per person really are not accelerating. What's accelerating are the attributes around the transactions. And as you can see, we're accelerating out of the knee of the curve. Already in 2010, the speed at which new data is available is phenomenal. So when you think about what we're doing, you think about what we need to handle in this area of big data, we've got to really work hard at bringing those things close together. How do we get the analytics and the processes closer to the data? As we look at this, I really don't like the term big data. What's the next generation call it? Bigger data? Biggest data? But what it represents and why in 2011 we seem to converge to that term is because there's this understanding, this acceleration that we can't use existing techniques, existing approaches to solve our current analytic problems that are being presented in businesses. So we can go to the next slide. We do a tremendous amount in the financial services. And about 40-some-odd% of our business is in the space of banking, mortgage brokers, insurance. The problem space here is really quite interesting. Just 2 weeks ago, Bank of America was presenting at the Analytics 2011 on marketing optimization. And the challenge of optimizing for customer satisfaction. I think this is one of the biggest shifts that we see going on as we talk about the changing landscape is the move from product-centric to customer-centric. Not just in retail banking, not just insurance, not just in retail, but also in healthcare. Every industry is in a process of transferring their thoughts around optimizing for product to optimizing for customer. It's not about what products I might sell to a customer, but what my customers want to acquire. What do they want to do? And we see this happening in the banks. As you think about marketing optimizations in the bank, we see them thinking about, I have, in this case, not one line of business, not one channel to the customer, and just some simple preferences. It's about 5 lines of business, all with their own P&Ls. I have a customer who has their preferences, their channels, their multiple channels they want to be touched in. And then I have my regulatory constraints. turns into a large optimization problem. How do we deal with that? Or I want to understand the value at risk of my portfolio. The challenges in the banks and the size of the data are tremendous. So if you talk about just understanding loan defaults, current techniques, understanding loan defaults in a large bank have to use sampling. Not necessarily a bad technique, but it is one that takes time and effort to reduce it down to a volume of data they can actually process. Or if we look at this area of the smart grid. Now you had the CEO of Duke Energy speaking last night. And there's a phenomenon happening here, which is at first, just the meters themselves generating data every 15 minutes. The regulators not understanding that necessarily forecasting every 15 minutes doesn't change, put regulations on forecasting on every 15 minute interval. How do you deal with that? How do you deal with that volume of data? And how do we deal with helping people understand what's the right data to do forecasting on? How frequent should that data be? This also represents a challenge to us of how do we turn these systems to be more autonomous? How do we deal with the privacy around these issues? One of the great examples that happened to Duke Energy is they were working on their pilot, their smart grid, as one of their employees, actually several employees are part of the pilot, had gone on vacation. Now, her energy spiked. They could tell from that energy spike that what had happened was that she had a leak in the hot water system. So they were able to call the plumber, send the plumber in, fix the hot water problem, fix the leak while she's on vacation. Now, is that an invasion of privacy? Or is that good customer service? We have another opportunity in these systems, which is in this huge flow of data, where do you actually put the optimization? Does the whole complexity of the system come back to the central control to optimize not just the distribution network, but down at the grid, the utility, all the way down to the transformer into the home? One of the things we've been working hard at is how do we actually structure the systems so that we can put optimization at each of those different places so you can minimize the amount of information that flows through the system. So there's a growing importance of analytics in every industry we touch. We simply can no longer use just our individual expertise because there's too much information to process. How many of you read Blink? Too many people took away from that book that Malcolm was talking about what you can decide here. There's nothing wrong with your experience. We are excellent computers. We do better probabilistic determination than most other computers. But when the amount of data exceeds the capacity, then you have to augment that. And that's really what he was trying to say in the book, is that you have to augment that capability of the expertise of the human being. You guys are doing a great job of remaking informs. To balance this, how do you bring the rest of business analytics into that? And the thing that we're finding, I think the thing that you're hearing here is how do you integrate that across the continuity of each of these disciplines. Operations research in itself is not sufficient for the problem sets. Data mining in and of itself is not sufficient for what we need to do. We need to challenge ourselves to bring these together where we can see some of that innovation occur. And we'll talk a little bit about how that has happened in the course of SaaS. We really are seeing a change in expectation. The consumerization of technology has happened. The smartphones make us think that we can do anything in our pocket. So we see every industry, whether that is markdown optimization, whether that's price optimization, whether that is marketing optimization, letting every industry an opportunity to take all this mass of digital information, systems where we had to make assumptions before no longer have to make assumptions. So now if we can deal with that in close to real time, we can completely change the interaction with the customer. But we have a problem, which is enough expertise that can help us build it into solutions. This is part of what's happening. We tried the period of black boxing analytics. Could we make it simple? Does putting a GUI on it make it simple enough? The answer to that was no. You can make it pretty, but it takes skills and expertise to establish the hypothesis to get the right answer. So that means how do you build that into the workflow process and into the actual solution? This is one of the one challenges that I think we have as we work through the educational process, which is how do we bring together the broader audience that wants to do it by helping those and understand the domain and the language and the flow of the process. Let's rewind just a bit. 1976. SAS has been in existence actually since 1968. In 1968, a set of universities studying agriculture data in the southern states as a consortium. Just so happened that the Triangle Compute Center, TUC, was available. So there was a centroid of compute capacity, capability, with the need of analytics that caused something to be innovative and change the game. Now, what's interesting in that process, and I'll like this quote. First, I didn't like this quote. This is one of the founders, John Salt. We were originally designed to analyze data on 9 cows. Over-engineered it. At first, my reaction to over-engineered was, do I really like the term? But it is correct. The great systems out there today are systems that have grown to be more than their original intent. They are platforms for XYZ. SAS is a platform for analytics. Google is a platform for mashups. Amazon turned their computing systems not to just be their extra capacity for Christmas sales, but into a platform for computing. So we see this across different systems that as you develop out, if you talk about a platform, we talk about SAS as a platform for analytics. One of the huge innovations was the abstraction of data. If any of you may watch Java conversations, they talk about just-in-time compile. The data step, the 4GL language in SAS, was a just-in-time compiled language in 1968. It is the engine behind doing credit card swipes for some of the largest banks in the world now in 13 milliseconds, running a 60,000 line score for a very complex model of understanding wherever you are, what's your context, are you traveling on business, are you traveling on pleasure, should this be a fraudulent card use. One of our histories of what we knew is we had to put analytics as close to the data as possible. So we had SAS data sets. Now you might recognize this pattern. Very wide avenues because we're in the world of analytics. Big block sizes, fast to pin, because you're going to go sequential processing all the time. In fact, in 1968, we wrote directly to the hard drives on an IBM mainframe because none of the abstracted systems were fast enough, because the data was big, and we wanted to put it as close as possible. Fast forward, how many of you have heard about Hadoop? Okay. Hadoop, the world's biggest hype in IT in 2011, which is, it's all about how I store big data cheaply and use MapReduce as a way to reduce it on a large grid. How's it designed? Very wide records, big block sizes, fast to pen. See the recurring model? Right? So this is really important as you talk about what's happening in this space of big data, which is the world has shifted to recognize that OLTP systems, the transactional systems, and storage levels for the systems, inappropriate. They were designed for getting information in. The whole generation of new databases, Netezza, Teradata, Astrodata, Hadoop, are all about organizing data for information out. How do you scale to that? So now, let's top of mind what's going on with SAS. At least 3 of the core 5 areas are right here. What's going on in high performance computing? We have a really simple definition of high performance computing. High performance computing equals high performance analytics plus high performance data. If you are unbalanced on either of those 2, you really don't have high performance computing. How do you focus on those models and those patterns? So if we take high performance computing and look at some of the different things that we've been involved in, you'll see that there are models about balancing the data. I'm going to go through a few of those examples because I think they're really valuable as we think about how do we look at high performance computing. And when I say this, we're really talking about commodity processors. x86, Linux. The world has shifted. This is what cloud computing has turned into. And this is what these specialized databases have turned into. So our partnership this year, in December, we'll be releasing a high-performance analytic appliance with Teradata and Greenfarm. That's the marriage of high-performance analytics with high-performance data as an appliance. To try to balance that, how do you get the data in and how do you get the data out? What are they? They're nothing more than a rack of blades. 16 blades, 12 cores per blade, 192 processors. You can cook some really good data with that. Visualization. How do we visualize big data? What innovations need to occur to make that useful for you? A scatter plot for 1 billion observations? Not very useful. A heat map to understand where you might see inside of that, to drill down, very useful. But I also want to put forward one of the things that we need to help the overall community understand is that visualization is best used when the brain, because it's so powerful, is using that to establish a hypothesis that we're going to test and control and validate. Right? Using visualization to make a business unit hunt and peck for an answer, not very effective. But it's really easy to get caught in that trap. We'll just give an easy visualization tool, put it on the desktop, let the users have it, let them make some decisions. Most of them will be wrong. How do we as a community come together to make sure we're working on the area? This other area is applying text analytics. We started about 10 years ago working on understanding what does it mean to bring unstructured content together with structured content. And that journey has turned into be quite interesting. What were one of the big shifts? So this is another slide we had in early this year with the R&D team. Does anybody want to hazard a guess what's the most important curve on this slide? The most important curve on this slide is the one at the very bottom. You see that growth in the number of cores. We geeked out and symmetric multiprocessing, the number of threads you could have, big box, big iron. We can go about as far as we can go. We've got the chips about as small as you can get them. 35 nanometers. If you're struggling to get any smaller than that because X-ray just goes right through it. So we started seeing this phenomenon. How do you put together lots of these processors? And that's really, when people are talking about high-performance computing today, they're talking about how to put together lots of these computers. And how do we program correctly to that to get the most out of it? Markdown optimization. A great example of value proposition and a shift. One of the big shifts at SAS as we've gone through being a platform for analytics is also our transformation we started 15 years ago to become a solutions company for business analytics solutions. This transformation of our customers asking us, look, we can no longer afford to build the systems ourselves. SAS will achieve it. And what we had to learn was to move away from being a tool, just a tools builder, but also build solutions with partnerships and deep partnerships with customers in every industry. And one of our first ones in the retail space with Kohl's, which was how do we do markdown pricing in every store for every SKU every day. A large, complex process that you need estimation because you mostly have sales data, you don't have demand data, but you're trying to forecast the price. And optimization is a big part of that, so now, right, you've got to bring estimation and optimization together. And one of the interesting problems here is the organization of the data for both those processes are different. So now you have to balance for both of those analytic processes, not one or the other. And this was really cool. And we went to Macy's and we sold this again. Signed, sealed, delivered. Love it, right? A value proposition, all done. And last November, the sales rep goes into Dr. Goodnight, president, CEO, says, would you please call Macy's and thank you for the business? Okay. He calls up Macy's, CEO goes, hey, thanks for the purchase. All right, it's really great. By the way, we're working on some of this high-performance compute stuff. We think we can drop your price of hardware by about 70% and solve your problem about like 1 order of magnitude less. Do you want them? He goes, yeah, sure. Jim calls Keith up, says, we got a deal. You got 6 months to deliver. We had been working on the research. We knew the problems there. We knew what we wanted to do. Now we had 6 months to go after it. And it has been extremely fun. A challenge, yes, but extremely fun. The speed at which we're changing. We did drop their costs for their hardware by 70% going to commodity grade. We took their compute time for Macy's across every SKU, every store, from 30 hours to 3 hours. So now, right, it isn't, oh my God, we had one hiccup during the weekend, we don't have all the prices for Monday morning for the rest of the week. It is, oh, if something goes wrong, I got some time. Oh, I'm a planner, I actually want to simulate this a few times because I want to see what happens. And when we showed this, Eric, where are you? Eric Doubleday. All right, there we go. See the hand right here? Eric's been on our customer advisory board for analytics, and he looked at us and said, this is what I love. Love about you guys, right? He goes, that's really good, Keith. But we do markdown pricing, we do everyday pricing, we do clearance pricing. And if you can do that now in 3 hours, let's tackle all three together. This is the world we live in. This is what's going to happen to us over and over, right? We're going to solve one part of the complexity, and we're simply going to add them up. There's no end to this opportunity that we're going to need skills to go and solve. So, markdown optimization, hugely valuable. High-performance data mining. What can we do in changing the lift? Look at this. 50% lift because we were more accurate, more simulations, across 1 million responders, millions of dollars. Now, this happens to be one of the classes of problems that is really large data. need to do with that. So we have the markdown optimization, organizing the data two different ways to optimize the process. We have customer intelligence around behavior modeling, which is big data, very wide, but a specific process. But we also have this one, which is value at risk. A small amount of data, very large number of simulations. One that is easy to go on its own, easy to expand the grid, because we actually don't have to have any large persistence of data. So part of the challenge is making sure we're abstracting the right models for high-performance computing. I talked a little bit about visualization. Nice and blurred here because we have to protect things. One of the things we did with LA County was to help them with their child care fraud. The proof of concept alone saved taxpayers $31 million. There are 6 years of history, 5 different input systems, looking for the relationships among groups of people. One of the things that we learn about fraud more and more is it's organized fraud. It's not a single entity. And then when you can find the relationships across groups, then you can find breakout fraud. And it's extremely valuable. And this was the outcome of a lot of analytics to be able to visualize the network. Because it turns out being able to show this to the caseworkers so they can understand it and understand the relationships is extremely important as you talk about visualization of large networks. Another interesting piece about understanding fraud in this space is that while we work really hard and you have all this conversation around the 360 view of the customer and the cleansed data of the customer, in fraud, you want all the dirty data. Every last drop of it. Because that's how they're gaming you. Change a name just slightly, change an address just slightly. But you have to make those soft relationships to understand that fraud. The really great thing about analytics is they go across every industry and they get to be used for different purposes. So the very thing that you do for network fraud here is the very same thing you do in telco for an influencer. So who's the most likely person to influence? So if they're at risk at leading, I can put all of my energy and effort on them. So the whole area of network fraud, influencer, extremely important. And as we move into social media, then we see the next place where it's important, which is the growth of social media leads us to changing the way we think. This goes right back to the same issue of the transactions from the previous graph and showing this shift of structured data, semi-structured data, and unstructured data in the move. So we have a lot of activity going on in this space. And one of the challenges is, of course, not just to see the social media. So it's really cool to be able to look at data together, but how do you take advantage of that? And our first breakout really was in warranty analysis. Right? In warranty analysis, it turned out that you could take the email logs and the tech logs, data mine them, and find early predictors for warranty. How many of you actually remember the TREAD Act, the whole debacle with Firestone and the rollovers? The outcome of that was learning how to use text mining to understand warranty issues as an early predictor so you could focus on those cases that were so important. What a big change. Fast forward. See this data? Right? February 2010. So we're part of a collaborative between North Carolina University and North Carolina State, SAS, looking at what can we do for NC Be Prepared, which is NC bioterrorism. It's interesting that North Carolina, with only 3% of the population, contributes about 25% of the national healthcare data. So we've done a good job at collecting healthcare information in North Carolina. We also have a fully enabled EMS environment to collect all of the logs from EMS. The researchers at UNC were able to show that an outbreak that they could predict at looking at hospital data in February, applying text mining to the EMS logs, would have predicted the outcome at the end of November. So the opportunity to impact our environment by bringing together the unstructured and structured data together is very, very significant. So you combine that together with what's going on in the Twitter sphere. How many of you are tweeting today? Good. It is an interesting phenomenon that's going on. Retailers, of course, are the ones that are paying attention the most, especially those in fast fashion, because their merchandise looks like perishable goods, and they need to make sure they're moving it appropriately. So when that happens, right, they want to understand who's influencing that buying activity. Who do they focus on? What's the activity? So this is a simple bubble chart, and work with Zappos at understanding how do they manage their brand out there in the ecosphere with blogs, Facebook, Twitter. What's important is not just knowing who's saying it, but also bringing in the social networks to know the influencers. So we're already seeing people, we're already doing a hosted software as a service for the social media analysis. So what's happening, what's being said where. We're also doing social conversation center, which is how do I manage a conversation once it's started. So if somebody says something that I didn't quite like on brand, can I manage that? How do I bring that to conclusion? The thing that we're also doing though is we're also capturing the key attributes so that we can actually model which of the answers were best. What's most effective? How do we begin to really help companies work with this very open landscape of conversation? And then how do we use the social network to understand influencers inside this space? So there's a tremendous amount going on in this area of social networks, how we bind that to the rest of our customer data so that we can understand customer behavior like never before. So, what does this mean? It means that there is just a tremendous importance to what we're doing to educate and provide research. You know, this community and the transformation you've had, right, from a downward trend in people that were coming to Informs to a switch that you added, what, I believe 700 new members? Very big shift. And it talks about what's going on in our landscape, about bringing together the different technologies. At SAS, we believe this type of collaboration is going to be very important. So we participate a lot. We have Manoj and Monica here. We have Kathy Lane, who's president of the Roundtable here. We have Bob Rodriguez, who's president-elect for ASA. This type of engagement is important. So we have some challenges, which is how to get people to have their ears open and collaborate. We used to be published in Paris in universities. Now we're IP in Paris. How do we deal with the patent process so that we can eliminate the motivations to say separate? If the patent process drives you apart, what do we change? Because we need collaboration like never before to accelerate the pace of innovation. How many of you just saw that Eric and Nelson just had a book come out called The Race Against the Machine? It's another one of these, oh my God, you know, machines are going to take over if we're not careful. Not quite. What he's really saying is that it's up to us to accelerate our pace of understanding, our education, our capabilities, so that we can manage this newfound power. This example of market optimization, getting people who understand estimation with optimization. We also had an interesting problem set in there, which is as you're trying to deal with constraints and you're trying to find convergence, you can actually look at some of the data mining tactics to actually change the convergence. So how do we look across disciplines? Very important. So this is something I hope that you guys are taking to heart, which is how to cross discipline fast enough to stay ahead. This happens to be a place that I find extremely important. Because how many computer science people do I have in here? I have a few brethren here. You know, our system of education in computer science is fundamentally flawed. The rest of you in here are responsible for fixing it. So one of the things we need to do is we need to change this conversation. I know there's a track here that's talking about IT and analytics. And I would submit to you that we teach computer scientists primarily about getting information in, not getting information out. So how do we change the computer science programs around the globe so they have a basic premise of 3 hours of statistics, 3 hours of econometrics, and 3 hours of operations research? So they even have a chance to have a conversation about balancing the information that we store in the systems with the information we get out. So as I traveled around in Asia last year, I was talking around the high performance risk. It was really very interesting because it was a repeating pattern every place I went. Go into a bank and you talk to the chief risk officer and you talk about being able to take their portfolio evaluation to the point where not at the end of the day's trade understand the risk, but potentially understand the risk exposure while they're trading. Huge impact. The CRO says, bring it on, right? Big honking grid system, 3 racks, thank you, I'll take it. Right? You walk into IT and they go, can we constrain that? Where was the conversation about the value proposition? How do we bring those together? We have a long heritage at NC State. Many of you are talking in your different universities about these analytics programs, how to change. The Masters in Analytics program today, proud to say, starting next fall, will double from 40 to 80. But it's still not enough. I just had a CIO advisory board last week, 18 CIOs together. Their #1 issue is talent. How do they have enough talent in their organizations? How do they organize to maximize the talent that they do have in their organizations? So we have a little time left, so I'd love to open it up for questions.